of you, to all the participants who are present here, our collaborator, that is Chandigarh Homeopathic Medical College. All of you. Okay, let me give you a brief introduction about Sympathy Institute. Sympathy Institute is a renowned institution for homeopathic pharmacy education. We have been running since 2009. It is the first homeopathic pharmacy education center in Delhi. The purpose of this webinar, what is the purpose of this webinar? The purpose of this webinar is to extend the knowledge of homeopathic pharmacy education. What are the developments and research that is being done in homeopathic pharmacy, in the field of homeopathic pharmacy. So we are organizing this webinar every month. The link of this webinar is present in the webinar group. You can join it every month, and we are putting this in the webinar group so that nobody misses these events in the future. Our topic for today is the methods that is used in the analysis of the drug and the test that is involved in such analysis. For today, we are going to talk about high performance thin layer chromatography. It is called HPTLC. To share his knowledge and his experience with us, we have Dr. Binit Dwivedi, sir. Dr. Dwivedi is an eminent scientist and a senior research officer at CCRH. Currently, he is placed at DP Rastogi Research Institute, Noida. Dr. Dwivedi has been working with this CCRH institution for a long time. He has been an author to many articles and many books that was published by CCRH. Welcome, sir. Welcome, Binit Dwivedi, sir. Let's continue with our webinar. And if anybody is having any queries during the lecture, you can write your questions in the chat box. Dwivedi sir will answer at the end of the session. Over to you, sir.
Thank you, ma'am, for your kind words. So I have not wasting time and I can start to presentation. My presentation is visible to all. From beginning, okay. The topic of my presentation is high performance thin layer chromatography. It is also called HPTLC. So contents of my presentation is introduction, principle, advantage of HPTLC over other techniques like HPLC, GC, and FTR, IR. So there are so many techniques. Difference between TLC and HPTLC, steps involved in HPTLC, derivatization, so that we can be compound derivatized and easily identify in HPTLC, and what is the instrumentation behind this, and what is the application of the HPTLC. So before we can know what is the chromatography. Chromatography was invented by Michael Twist in 1901 during his research on plant pigments. Actually, Michael Twist invented chromatography first. So he was experiment on plant pigments. So what he did, because plant pigments are colorful compounds, some are yellow, some are black, some are white. So it is easily to identify. So what he did, he used techniques to separate various plant pigments such as chlorophyll, xanthophyll, and carotenoids. So what is the chromatography? Chromatography means chroma means color and graphy means writing, color writing. So Michael Twist named his techniques chromatography based on fact that it is separated compounds by solution by color. Actually nowadays there are so many compounds which are colorless. So theme is changed. We can detect by the derivatization technique and by the UV and other detectors. So that we can detect the colorless compound also. Common types of chromatography: paper chromatography, cellular chromatography, liquid chromatography, and today what we are discussing, that is HPTLC. And other is ion chromatography, gas chromatography. We are not discussing today. We are discussing only HPTLC. So this is the basic experiment done by Michael Twist. What he did, he take a glass column and filled with this column filled with calcium carbonate, and he prepared ethyl alcohol extract, and he prepared ethyl alcohol extract of these pigments and applied the top of column. Ethyl alcohol is used for plus for pigment down the column. What is the end of this? A series of color bands is seen in the form corresponding to the different pigments in the original plant extract. These bands were later determined to be chlorophyll, xanthophyll, and carotenoids based on the color. How does chromatography works? In all chromatographic separations, the sample is transported in mobile phase. The mobile phase can be gas, liquid, or supercritical fluid. The mobile phase is often pushed through the stationary phase, held in column or in solid surface. The stationary phase needs to be something that does not react with mobile phase. Means the stationary phase is that like that, it should not react with mobile phase. And the sample which was to analyze, the sample has the opportunity to interact with the stationary phase and moves it fast to it. Sample that interact greatly then appears to move slowly. Sample that interact weakly then appears to move more quickly on the top. Before of this difference in rates, sample can be separated in their components. This is the graphical representation how compound are separated in the TLC. Initial stage, this is all as in the bottom line. This is the sample mixture. And when we take mobile phase, the eluting solvent begins to flow through the solid phase. And after this, sometimes the solvent move on component and mixture moves in different rates. The less polar compound travel faster and go the top on the plates, and the more polar compounds travel slower due to polarity. So they are separated on the bottom line. And before we go for HPTLC, we also need the thin layer chromatography because the HPTLC is the advanced form of thin layer chromatography. In thin layer chromatography, solid phase is mostly silica or alumina. It's applied in thin coating on a plastic or glass sheet. It's called TLC plate using capillary tube. A solution of sample is applied on the solid support as a spot. This technique is known as spotting. When the sample dries, it becomes absorbed onto the solid support. This process can be repeated several times to produce a more concentrated spot. What is the spotting techniques? Before we start the spotting, we take a pencil, dry horizontal line about 1 centimeter from the bottom of the TLC plate to mark the starting point of the sample for illusion. Dip the capillary micropipette in the solution, sample to be analyzed, capillary reaction will cause the liquid to rise up pipette. Lightly touch the solid support with the tip of micropipette and a small amount of solution will transfer to plate, forming spot 3 or 4 application of the same solution will be suffice to produce a good spot. If you are applying several samples, spots must be separated by a minimum distance by 0.5 centimeter between the two spots. Spots should be separated from the edges by between 0.5 centimeter, except for the bottom of the plate, in which case they should be separated by a minimum 1 centimeter. The region of this plate should be immersed in the eluting solvent to effect the separation, and the eluting solvent should not touch the spot when the separation begins. This is the separation of compounds in the TLC plate. Initial TLC plate we mark the 1 centimeter as I discussed, but with pencil. This is the initial spot. TLC plate inside the developing chamber. We put the TLC plate in developing chamber. This is and using the solvent. The solvent are going through the polarity base and the compound are separated. This is at 1 centimeter from the top, we have to stop so that solvent cannot be overlook the plates. So the good solvent causes good separation components of mixture. This is the separation, how separation takes place in the HPTLC and TLC plates. A relation between the RF value. RF value is unique of the compounds to be separated. The more polar spot travels slower because polarity is high, so compound goes lower, and less polar spots travel faster in TLC plates, and the compounds fast and go to top. The RF value, on the other hand, are directly related to the rate of movement. The hardest moving spot has the highest RF value. The compounds who are fast, less polar are have highest RF because this moves faster on the TLC plate. Therefore, RF value and polarity are inversely related. The spots which are highest RF value are least polar, fastest moving, and the spot with the lowest RF value is the most polar, slowest moving. Use of RF in TLC. RF values are frequently used to compare a known and unknown compounds to determine if they are same as long as their spots are run simultaneously on the same plate. The argument can be made on the same RF are the same. If the general appearance of the spots is the same, they are the same compounds. If we take the same TLC plates and put the same compound and we get the same RF value, then we can say these compounds are same. The RF value depends on polarity and the polarity of solvent, polar nature of stationary phase, polar nature of sample, condition of experiment. RF values are therefore not exactly reproducible from one experiment to another because the conditions are lab or must be same. When comparing two or more substances, they must be run simultaneously on the same plate, then comparison are invalid. So this is the difference between HPTLC and TLC. The parameters like chromatographic plates used handmade in TLC we can prepare by hand or pre-coated. In TLC, HPTLC, we can purchase by pre-coated uniform thickness plates. Absorbent thickness 250 micrometer in HPTLC, 100 to 200 micrometer. Particle size here also we can say 5 to 20 micrometer in HPTLC, 4 to 8 micrometer. Pre-washing of plate not followed in TLC, but HPTLC is must. Application of sample, we can applicate of sample by manual or semi-automatic. In HPTLC, it may be semi-automatic or fully automatic based on the instrument purchased. What is the shape of the spot? In TLC, this is the spot. In HPTLC, this is spot or band. The spot size 2 to 4 millimeter, here 0.5 to 1 millimeter. Sample volume, we have to take 1 to 100 microliter. In HPTLC, we can use only 0.2 to 0.5 microliter. It is sufficient for the separation of compound. Application of larger volume spotting which leads to overloading. Here in HPTLC can be applied as bands. Here the TLC plate size 20 by 20, here only 50 to 20 and 40 to 50. Optimum development distance in TLC, this is the 10 to 15 centimeter. In HPTLC, only 5 to 7 centimeter. So this analysis can be fast and accurate. We can save the time because the sample travels up to 5 to 7 centimeters. Development time, it depends on mobile phase, 40% less than TLC. And the reproducibility of gel, here in TLC, reproducibility of gel different because the uniform, they are not so no type to prepare uniform handmade TLC plates. In HPTLC, these are reproducible because uniform thickness are available and there are some glass plates and uniform coating, and based on the compound, we can also purchase the HPTLC plates. So this is HPTLC is based over TLC. So we can discuss here now on what is the HPTLC and how we can perform HPTLC. HPTLC, also called high performance thin air chromatography, is automatic, sophisticated from an improved method of TLC. It is powerful analytical method equally suitable for qualitative and quantitative analysis. In HPTLC, we can quantify the compounds, whereas in TLC it is not possible. It is also known as planar or planar bed chromatography. HPTLC is very popular for many reasons like visual chromatogram, multiple sample handling, enables the most complicated structure. In HPTLC, we can take 10 samples from different manufacturers or different places at a one place. We can see the results because this is the open chromatography. This is the process how can we compare selection of chromatographic layer, sample and standard preparation, pre-washing of HPTLC plates, application of sample standards, chromatographic development, detection of spot scanning, and documentation of chromatographic plates. We can explain one by one. Steps involved in HPTLC. HPTLC solvent. Generally, same solvent used for dissolving both sample and standards. That if we are analyzing by Ravalpur, serpentine, and diazepine, then we have to separate the same solvent in which we can prepare the mother tincture, and diazepine also soluble in that. So same solvent can be used for the quantification of compounds in the HPTLC analysis. Commonly used solvents are methanol, chloroform-methanol 1 by 1, ethyl acetate methanol 1 by 1, chloroform-methanol ammonia 90, 110 or 1. Methyl chloride methanol 1 by 1 ratio. 1% ammonia or 1% acetic acid also can be added for the base separation in the HPTS. This is the mobile phase selection. Based on polarity of compound to be separated, this is the polarity strength. Hexane is less polar after that cyclohexane, carbon tetrachloride, toluene, methylene chloride, tetrahydrofuran, acetone, ethyl acetate, aniline, acetonitrile, ethanol, methanol, water. Water is the most polar, polarity index is 1. So based on the compound selection, separation, we can choose the mobile phase. It is based on the compound to be separated in normal phase, where normal non-polar solvent are used. In non-polar compound will be move fast and on PTLC plate, while other polar compound will be stay on the baseline. Inversely, polar solvents such as water, methanol compound to be moved from the origin. So based on the compound separation, we can pick up from these solvents from this table to understand the polarity of the compounds. This is the commonly used mobile phase for the separation of compounds. Suppose we want to separate the cardiac leukocyte or saponin from our compounds in the mother tincture or any homeopathic medicine, then we have to choose ethyl acetate, methanol water, 10, 13.5 and 10 volume by volume ratio. Based on these, we can change slightly mobile phase if we are not get desired result. If we want to separate alkaloids, then we have to go toluene, ethyl acetate, diethylamine 70, 20, 10 ratio. But when we not got result, then we have to modify some, like we take 70 or 25 or 10. Based on the experiment, based on the experimental procedure, we have to modify these mobile phase to get best results. In like flavonoids, we get ethyl acetate, formic acid, glacial acetate, water. Saponin, if you want to separate saponin, then we have to go chloroform, glycerol, acetic acid, methanol, water. Like we want to separate coumarin like in coumarin, that is the bacterioactive compound in the curcumin or curcumin state, then we have to go diethyl acetic toluene or saturated with 10% acetic acid. If we want to cardiac glycoside, then we have to choose ethyl acetate, methanol, water, 100, 30.5 and 10 ratio. Cardiac glycoside is very important for the cardiac drugs. If we want to create cardiac drugs, so we go for this analysis. If we want an essential oil, then we have to choose toluene, ethyl acetate, 93.7, 93 or with 93 and 7 volume by weight ratio. If we want to isolate terpenes, then we have to take chloroform methanol water 65, 25 and 4 ratio. Same triterpene, ethyl acetate, toluene, formic acid 50, 50 and 15 volume by volume ratio. What is the stationary phase in HPTLC? HPTLC, very few handmade plates are available, but it is specific analysis can be used, like celluloid, micro crystalline celluloid, without suitable one that can be used for the some specific analysis. Pre-coated plates. Commercially, pre-coated plates are different images are available. This is very used plates are analysis. Pre-coated plates are being preferred over handmade plates as they offer uniform and dense absorbent layers. So we have to choose only pre-coated plates for the analysis. This is the details of plates. HPTLC plates are available in 20 by 20 centimeter, in 10 by 10 centimeter, and 20 by 10 centimeter, 10 by 10 centimeter. Based on your requirement, based on sample. If you have less sample, then you take 10 by 10. If you have more sample, then you take 20 by 10. Based on the sample size, we have to choose the HPTLC plates, and the HPTLC plates are readily available in market. This is the details of HPTLC plate for the procurement of the market. And this is the commonly HPTLC plates based on your compounds. Like if you want to separate aflatoxin, alkylate, fatty acid, flavonate, glycoside, lipids,
বুঝলাম
nucleoside,
ভাই
proteins,
সেভাবে
peptides,
ওডোমাস লাগাইলে
sweeteners,
মুখ গুছায় না
then you have
ঠান্ডা
to choose
পড়ছে
sulfagen. Like if you want to isolate the aliphatic compound, then you have to choose aluminum oxide HPTLC plate. If you want to analyze the biomolecules, then you have to choose cellulose HPTLC plates. This is the steps involved in HPTLC selection of plates. The selection of the chromatographic plates in HPTLC depend on nature of material to be separated. Commonly used absorbent I have already discussed silica gel, alumina, cellulose, polyethyl, depends upon your analysis. The particle size I have already discussed 4 to 8 micrometer. Now we have to pre-washing. Before we start, we have to pre-washing our plate. Prior to actual chromatography, the plates are pre-washed to remove any adhering impurities. Before analysis, we had to pre-wash the HPTLC plates. This is done by developing them solvent like methanol, chloroform, ammonia by ascending or descending methods. This helps to avoid any appearance of dirty joints on the spots. Plate activation. We have to activate the plate. Freshly opened box of HPTLC plate does not need activation. When after some time we had to perform analysis, then we had to activate the HPTLC plate to get desired result. In HPTLC plates exposed to high humidity or kept in hand for long time require activation. Plates are plates and place oven. Plates are before after activation process we have to put the plate in oven at 110 to 120 centimeter 120 degrees centigrade for 30 minutes to activate. After the activation, we have to start the process. Then we have to put the sample in the sample plate in the chamber. So precondition of chamber is also required. We cannot put the direct in the chamber. We have to saturate the chamber also. For this we have to precondition of HPTLC chamber is required, but if we send separation, it is not required when non-polar solvent is used. When we are using polar solvent, then it is highly recommended to use these types of synthesis, but for which we have to separate chamber saturation for 20 minutes. The tissue on the top of the chamber. Application volume. To obtain better regulation, both standards and samples are to be applied in volumes of 1 to 5 microliter in the form of bands. Application carried out by Linomate application on the plates, which give uniform and safe standards to get best results. Scanner. Advantage of densitometer in scanner. When we are going to quantification of the compounds in HPTLC, then we have to use scanner of the HPTLC. The purpose of a scanner is to convert the spot band into the densitogram considering a peak similar to HPLC. As same peaks we have to collect in HPTLC like HPTLC. So in this purpose we have to use densitometer scanner. The position of the scanner peak on recorded chart is related to RF value. Quantification is faster, reliable, accurate, and reproducible. Now we have to start HPTLC analysis. How we can perform the HPTLC analysis of mother tincture, because mother tincture is the primary drug for the starting of potency in homeopathy. So when we standardize the mother tincture, then we have to confirm that the mother tincture is standardized. Mother tincture has this amount of compounds of biomolecules. Then we have to say that if this compound is present in mother tincture, this compound may also be present in the potency. So we have to focus on mother tincture So analysis by HPTLC. So what we do, we prepare the mother tincture. Mother tincture prepared in house as per homeopathic pharmacopoeia of India. Or when the compounds, when the different formulation are present, which is not available in pharmacopoeia, then we have to perform maximum extractive value in the lab, and we start the preparation of mother tincture in our lab. Preparation of reference standards. When we have to analyze the compound like double phase serpentina, we want to isolate the compound, we want to quantify the compound standards in reserpine, then we have to prepare the reference standards, reserpine. We purchase the reference standard from market reserpine and dissolve 1 mg of reserpine in 1 ml of ethanol in volumetric flask and sonic it and to prepare working standards with the concentration of 1 mg per ml. Preparation of chloroform extract. Since the compound is alkalides, then we have to prepare the chloroform extract. For the preparation of chloroform extract, we take 25 ml of mother tincture, was taken in the 50 ml beaker, and the compound is evaporated in the ethanol, and extract 3 times of chloroform there, and we prepare the chloroform extract up to 2 ml for HPTLC analysis. Preparation of alcoholic extract. Some compounds are all available in alcohol extract. For that, we have to prepare the alcohol extract. So for alcoholic extract, we take 25 ml of mother tincture, evaporate on water bath, concentrate to 2 ml. 2 ml is the thickness, 2 ml for HPTLC analysis because when we concentrate the compound, then it is better for spotting. Because this is the concentration, and it is good to take the 2 ml and take the micropipette for the HPTLC analysis. So we have to prepare up to 2 ml. We have to concentrate up to 2 ml in chloroform or alcoholic extract for HPTLC analysis. HPTLC analysis will perform on chloroform or alcoholic extract, as I have discussed earlier, for mother tincture using HPTL system. Sample will applied using ATS5 on pre-coated silica 60 F to 54 plates. We had to take 20 by 10 centimeters because we had so many samples on one plate. This is the beauty of HPTLC. We can perform so many samples on a one plate. And while in other techniques, we have to perform different analysis. In HPTLC, we have to perform 10 analysis at one time by taking 20 by 10 centimeter HPTLC plate. Mobile phase will be standardized before the analysis, and the chromatogram will develop in a saturated twin through chromatographic chamber. HPTLC develops on a distance of typically 70 millimeter as per USP guidelines, and analysis time not more 20 minutes as per international SOP. The developed plate will visualize under UV 254 nanometer or 366 nanometer based on the compound analysis. And visual light, we can also derivatize the visual compound in HPTLC for the best result. The peak of interest would be resolved between distinct RF on HPTLC plate. Chromatograph development. HPTLC plate are developed in the chamber, as I have discussed earlier, and we have to detect the compound based on the UV or 266 nanometer compound. Detection of separate compound on their absorbent layer is enhanced by quenching fluorescent due to UV light or due to fluorescent light 366 nanometer. So this is the visualization and derivatization. Fluorescent compound should be described as fluorescent quenching. The quenching should be sent by all encephalopodides, coumarin, flavonoids, polylenic acids, and some alkaloids of Ravelkia can be also checked in 366 nanometer. Visualization and white light. Some compounds also available in the white light, so we can directly see in HPTLC plate in white light. With the compound which is not available or which is not seen in white light, then that compound can be derivatized with the derivatization reagent in HPTLC plates. Compounds that are colorless and cannot be visualized in UV or 366 nanometer, that is go for derivatization reagent. A suitable reagent is applied to the HPTLC plate based on the compound, because all compounds not come in the same derivatization reagent. Based on the compound nature, we have to choose derivatization reagent and derivatize with plate to detect the compound. That compound also react with sample compound and transform them into detectable derivative in HPTL secrets. Now I take one example of the Syncona officinalis. We take Syncona officinalis, this is the Syncona officinalis plant, collect the bark of these plants and perform HPTLC analysis and UV 254 nanometer, UV 366 nanometer, and after that some compounds not come in the UV 254 and 366 nanometer that we had to derivatize by Dangan-Drop reagent because compounds are alkalides. Then we had to choose Dangan-Drop reagent because in the Syncona, the Syncona plant is rich with alkalides. For that we have to take Dangan-Drop reagent. Otherwise we take any NCLER, sulfuric acid or other. There are so many derivatizing agents. So what we do, we take Syncona optionalis and prepare the mother tincture and perform HPTL analysis as I discussed earlier. This is the 254 nanometer. We have CRC. These compounds are separated in the zones, in the bands. Along with this is the reserpine single spot. We can say that the reserpine also present in the say all sample in the HPTL plates. This is the reserpine where we got only single spot because the reserpine is single compound available in the market and available in the HPTLC plates. So we can put HPTLC plate single marker compound. This is the Symphony standards. We take 1, 2, 3 track of the Symphony standard. After that we take 4 to 6, 4, 5, 6 track in-house mother tincture prepare and 7 to 9 markets. So let's we take one example of Syncona optionalis for which we have performed HPTLC analysis. So for this example, all can understand what is the process, how we can perform HPTLC analysis of the homeopathic plants. So this is the Syncona optionalis plant, but in homeopathy, we can use bark. So we take bark, we can we can grind the bark and they prepare the mother tincture for HPTLC analysis. We'll prepare the mother tincture and evaporate up to 2 ml for HPTLC analysis and perform HPTLC at 254 nanometers. Now you are saying that this is the reserpine track. 1, 2, 3 is the single compound we have to purchase from Sigma to confirm where the mother tincture having reserpine in this mother tincture or not. So this is the 254 nanometer and this is the 366 nanometer. This is the derivatization reagent. Because some compounds are not visible in 254 or 366 in white lights. That compound can that compound we had to change that compound nature by derivatization with Dangan-Drop reagent because compounds are alkalides. So we choose Dangan-Drop reagent for visualization of that compound. Now here we are saying that the track 1, 2, 3 is the Symphony standards and track 4 to 6 the in-house mother tincture and track 9 to 7 market sample and track 10 to 12 market sample B. We take 2 types of samples, sample 1, sample 2 from market, and also we have prepared mother tincture in-house to compare the quality of in-house mother tincture with market, and we also check the Symphony present in market sample in-house sample or not. So we purchase Symphony standards. Here we see 1, 2, 3 the single compound. We have to see the single spot in HPTLC plate because the single compound is there. In the market sample, in mother tincture, there are so many compounds, so there are so many bands. But all mother tincture have Symphony standards. So we can say that the standards, the mother tincture prepared from in-house and market are genuine because all have synchronine in their combination of compounds. So this is the result of the HPTLC analysis. In 254 nanometer, we got 5 spots at RF 3.137 brown spot, at RF 0.48 brown spot. In spot number 3, that is the standard synchronine, that RF is 0.58 and other is 0.78 and other is 0.79. Same type in UV 366, 0.17 blue, 0.39 blue, This is the unique fingerprint, unique standards of HPTLC. So we can check the adulterated sample, market sample, and other sample you want to check the quality, purity, efficacy. Then you have to perform these types of HPTLC analysis. But what we do, we can perform UV 254, 366. Some compounds are not visible at HPTLC at 254, 366. That compound we have to derivatize by derivatization reagents. The third part is the derivatization agent. So what we do, we derivatize the HPTLC plate in Jangen's reagent, and we got 0.37 RF at orange spot and 0.48 orange spot and 0.58. You can here see 0.58 RF is the standards, and we got all mother tincture 0.58 standard. This is the symphony, and the other compound is 0.67 and 0.79 orange. This is the derivatization. So this is different compound, in UV different compound, in UV 256 and 366 nanometer different compound. So there are so many unique pattern of HPTLC analysis. These can also be used for adulteration checking, for quantification checking, for the adulteration checking, for the confirmation of the genuineness of mother tincture prepared in-house, in your lab or in market. You can easily check in market sample there is the authentic sample or not by performing HPTLC analysis. Now we can say what is the application of HPTLC. These HPTLC fingerprint may be used as reference standard for quality control of homeopathic drugs. HPTLC fingerprint can be used for identification of adulterant. If your sample is not matching with the HPTLC, then you also say that sample is not authentic. This is adulterated with other plant, same plant species. So you can also check the adulteration by HPTLC. And whereas substitute may be same types of like Ravalpia serpentina, some seller can you provide Ravalpia tetraphylla. This is the substitute. So you can also check this by HPTLC. So HPTLC helps in the adulteration and substitute, helps in the differentiation of various plant species simultaneously at one time by HPTLC plate. Therefore, it can also be used for evaluation of different market sample. This can also be used in HPTLC in homeopathic pharmacopoeia of India, also used in other pharmacopoeia of global. We can also exchange the pharmacopoeia pattern of America and other countries. So we can also check because these HPTLC are international standards. So these standards can be used as global standards for homeopathic drugs. This is some examples. We can also check an HPTLC qualitative analysis of steroids, reducing sugar, triterpene, sugar, alkaloids, phenolic compound, flavonoids, saponins, tannins, and terpenon. These all are active compounds. We can also check the HPTLC by the only quantitative parts. These can also be determined by total alkaloid, total phenolic compounds, total alkaloid, total saponin by company samples and with purchase of reference sample, and we can easily quantify the compound like in Ravalpia serpentina, how many reserpine in the present in the your mother teacher and in your homeopathic drugs. These can also be quantified by HPTLC analysis by using HPTLC scanner. So this is the my book. You can also, if you want more information about HPTLC analysis, this book has consisting of 50 plant standards. This book also useful for your as a reference. You can purchase from market, and for more detailed analysis, if you want details of HPTLC, because the HPTLC is very long subject. We cannot cover in 1 hour. So you can refer this book for better understanding. So thank you. This is the HPTLC instruments. This is the scanner. This is the Linomet 5. This is the computer where we got all the screen. Thank you.
Thank you very much, Dr. Binit Dwivedi, sir, for your amazing knowledge that you have shared today. This knowledge is very priceless. I don't think it will be available anywhere else. We would like to present to you a digital certificate as a speaker for today.
Sir, we are proudly presenting you for the valuable contribution to the success of this webinar on the topic of high performance thin layer chromatography. So this is for you, sir. Please accept it, sir.
Thank you. Thank you.
Thank you very much, sir.
Thank you for your works and the certificate. I will provide all information. If you have any more question, you can ask, or you can directly touch, or you can send all information or any question to my mail. I can also provide the information to the mail also. No.
Definitely, sir.